Thank you. Well, I'm Berislav Todorovic. I'm working for Juniper Networks for professional services, and I've been dealing with a lot of customer implementations recently where IPv6 gets more and more attention, and those customers are using MPLS. So at the very beginning, I would just like to have a survey. How many of you are using MPLS in your network? Okay, yeah, I know. There are some people that say like this. Okay, I will explain that also, but the market share says something else. Okay, I can understand that for internet operators it's not a must, but so how many again? Okay, okay, I guess mobile operators or telecom, or yeah, just thought so. Well, and how many people in this room are not familiar with the MPLS at all? Just don't be shy. Okay, it's nice, yeah, you don't need to be. I'll just get a really, in 1 minute, course of MPLS which within this presentation, which will be really a quick one. So, what is this presentation about? When, let's say, I will first talk about how we came to what we are, where we can fix this. No. Okay. Well, someone literally pulled the plug, I guess, when I told so that was a bad thing to say. Yes. Ah, okay. So, why this presentation? As you can see, the IPv6 world is emerging, and not only the world, but standards are following it. Back in 2012, IETF came with a nice informational RFC7439, which stated all IP equipment should, or even say must, support IPv6. That's a recommendation. I guess it doesn't say must, it says should, unfortunately, and that's why people are still launching devices and services running on IPv4 only, unfortunately. Then Jan came with a nice document, what you need to check on IPv6 requirement when you do public procurements and RFPs. Thank you, Jan. Great work. And finally, last year, the Internet Architecture Board and IETF issued a nice statement saying, from now on, we will not develop any standards further for where IPv4 is assumed. So first we handle IPv6, and then if you have time, we handle IPv4. Wow, that means that we are slowly emerging with the new standards and features towards the world not having IPv4. Okay, so we don't have a connectivity again. Yes. Pazi. Ne. Nešto sa projektorom nije. Aha, time out. Aha. Aha. Great, now this... Ovo sam pritisao. Ovo sam pritisao. Okay. Okay, I guess I have a really strong hand. That's the problem. So, As I said, well, MPLS is unfortunately still there, although it was envisaged for a completely different use case. People are using it still today. And why? Because it provides it provides routing context separation, VPNs, traffic engineering, fast traffic restoration, and the latter use case is very popular, especially among mobile ATM and IP. Someone said, okay, we will include a small label between the layer 2 header and the IP packet. And based on that label value, each router between the ingress and egress network in your network will examine only the label value and will not take a look at the destination address of your IP packet. Back in 1990s, this was a really great achievement because the routers back in that time were slow, and really some kind of label, jumbo was necessary to speed it up. But the myth of the thought that MPLS will make forwarding in your network faster is these days, of course, a myth, because it's whether you're going to look at the label or at the IPv4 address, everything is being looked up in the hardware, in the ASICs. So regarding the forwarding speed, you're not gaining too much anymore. But still, you have some advantages that I mentioned already before. Also, one of the things that I would like to pay attention to is in the original RFC3031, which describes the MPLS header structure and packet structure, it says that you have an IP packet. IP packet can be an IPv4 and IPv6, of course, but again, here between the layer 2 header and MPLS header, behind that, you can not only have an IPv4 or IPv6 packet, but you can also encapsulate a whole layer 2 packet, and with that you can build layer 2 VPNs. So far, so good. IPv6 can be supported in MPLS networks, at least in the forwarding plane, where packets coming to the ingress routers are being added a label, which is being swapped at each P router, at each core router on the path between the ingress and the egress. So for instance, the original label 50 we swap here with label 20 based on the interface where we receive the packet and the value of the label. We look at that value and we say, okay, all packets having label 50 coming from interface 1 should be swapped with label 20 and pushed towards interface 3. Finally, on the ingress, at the egress PE, we pop the labels and further the forward packets using the classical IP forwarding. That popping and pushing labels provides us some kind of thought that we have a fixed path in the network, and we call that a label switch path. Now here you see IPv4 addresses again. So the question is, can those be IPv6? So you can see IPv4 addresses. Of course they can, but as you will see, there is that but ... that is making problems to us. Before I explain that but ... I will get a bit about what is an additional mechanism in MPLS, that instead of having one single label, we can push a stack of multiple labels one behind the other. So that's what the original specification provides us. Where is the use case for that? Well, we can ideally assign a label to each packet between the customer router and the provider edge router, and then based, for instance, the packets coming from router A will be assigned label 11, packets coming from customer edge 2 will at the egress router be assigned label 12, and then push another label, which is called the service or the transport label, and all routers between the ingress and egress will only swap that outer label while preserving the inner label. Guess what? We can use that mechanism to build separate routing contexts or VPNs. Because in that case, the red labeled packets will belong to VPN A and blue labeled packets will belong to VPN B. So we have a great mechanism to build network-based VPNs and to build several routing universes on the routers, several routing in parallel, several routing tables that can overlap with each other. The same thing we can do with the layer 2 packets by pushing one service label and one transport label, and so we can build layer 2 VPNs. The service label is constant within the network and the transport label being swapped at each pop between the ingress, the egress. Now we come to the question, so if we can put here an IPv4 or IPv6 packet, what is the problem then? Well, you can ask yourself, all those labels, how are they assigned? We know that within classical IP forwarding, the forwarding tables are being populated at each router using some kind of communication among the routers, or in these days within from an SDN central controller. But still, we do need some protocols. In the classical forwarding, we are using routing protocols to exchange routing tables, right? IGPs and BGP. The similar mechanism and protocols are used by MPLS. They're being called MPLS signaling. And for signaling of those green labels that are just being used for forwarding packets, those are called MPLS transport signaling protocols. People among you already probably know about LDP and RFC7439 and so on. The problem is, those protocols, which are indeed very simple, the egress router, each router in the network assigns a set of labels towards its peers. The peers accept those and generate a set of labels downstream and so on, and they build label swapping tables at each hop. The problem that appeared is all those protocols were written, and software is originally written for IPv4 only. So the question is, when IPv6 came into the game, people started having problems, and they said, ouch. Another use case where MPLS didn't cover correctly from day one in the 1990s was multicast. Originally, MPLS was built for unicast only. Well, people started asking for multicast, and even some nasty people asked for IPv6 now multicast. Over MPLS, we said, ouch. Well, another issue, and that is a side of MPLS transport, which takes care of how to forward packets, we need to also take care of the service part, or content of the VPN routing tables, or content of the L2 VPN states. How do we signal that among the network? How do we know that those networks 192.0.3.0/24 belong to the VPN A? The same thing can be with IPv6. Well, we are using something called multi-protocol BGP. Again, as you will see, multi-protocol BGP is a great thing, and although RFCs are pretty much unclear, most implementations so far are built both open source and vendor specific, proprietary, are built on IPv4 only. So, as a summary, we have protocols for transport signaling and protocols for service signaling. And guess what? And you know probably some of them, like LDP, RSVP-TE, BGP labeled unicast, and segment routing, which is the novelest and the newest transport signaling protocol. And on the service side, we have layer 3 VPNs using MPBGP, layer 2 VPNs using LDP, or some other services using still MPBGP. So the question is, can we use those protocols with IPv6? Well, yes and no, but most of the time, unfortunately, no. And that's a bit of, I'm having a bit of an unpleasant task to tell you bad news. So, but bear with me, there is something that you can do. As you can see, IPv6 has been very important to the customers from day one, although back in 1998 we didn't have mobiles, we didn't have broadband internet connectivity, social networks and so on. So people probably didn't take care about IPv6 network connectivity. Still back in 2003, the first solutions how to push IPv6 packet over MPLS networks appeared. And there are some solutions that people running MPLS probably know very well, and those are, the first one is just push IPv6 in parallel with MPLS, so don't care about MPLS, just use classical forwarding for IPv6. That's called native IPv6 over the core. In parallel, you're using both infrastructure, which is good. However, it creates with large network an operational mess for your people having to troubleshoot both IPv6 forwarding and MPLS forwarding and IPv4, and they will just go nuts. A more elegant solution, which was proposed as a transitional mechanism, but still very popular these days, is the 6PE. I will show you on the next slide. And 6VPEs are basically IPv6 VPNs over MPLS networks. However, all those mechanisms are based on a philosophy: do not touch the IPv4 core, just run IPv6 on the edge and preserve your IPv4 core. Well, not a very lucky solution, but it works. So what you have here is that your IPv6 customers will, for instance, establish BGP sessions with your network, and the PE routers within your networks will run native IPv6 facing your customers, and on the other side, they will talk MPLS to the core, pushing IPv6 packets over the MPLS infrastructure. And the MPLS infrastructure will use IPv4 for signaling. So what you will have here is you will use eBGP for service signaling between the PE and the CE, and MPLS, multi-protocol iBGP between the PE routers using IPv4. So what that means is you will, in the end, create the IPv6 services which are running perfectly fine. The customers will probably not notice anything, and in your core, you will still preserve an IPv6 agnostic area anyway. People are very happy with that solution. It works, it is stable, but it requires you still to run both IPv4 and IPv6 in your network. Luckily, IPv6 only on the edges. The question is, having in mind the newest developments in the industry, in the standards, what will happen if I need to build a new network and I want to build a greenfield network with IPv6 only, or if I want to pull the plug on IPv4? Of course, I will not do that on an existing network, but if I build a greenfield network, what if I want to run an IPv6 only network? You think it's sci-fi? Well, it's not. Peter Lodberg did that as an experiment, building his TerraStream, and he was running IPv6 native over optical infrastructure. You can see his presentation from the RFC67 meeting. Also, there are some other ideas, like IPv4 can be moved to the edges 4P instead of 6PE. And what would be a good use case of why should I run IPv6 only in the network? Well, it's operationally simple. It mandates me to use only one protocol stack and take care of all ACLs, firewall routes, and everything else, and management using IPv6 only. And use IPv4 as a service. That as a service is very popular these days. Nice thought, but for MPLS, it's still not possible. So at one point in time, I built in our virtualized environment this topology, but this topology is not something I invented. My colleague Krzysztof Szarkowicz wrote a nice book, MPLS in the SDN era. It is a really nice one, and I borrowed this topology from him. It's a really simple one. It has four PE routers, 2 core routers, 2 route reflectors, and 4 CE routers. And I gave them IPv6 addresses, as you see on that picture. And I established LDPv6, and separately I established Spring v6. Whoever is interested in a demo can approach me. Separately, I can run and show you in the hall or somewhere. I can rebuild the topology again. And here is the trace route I obtained. As you can see, I could manage to get IPv6 signaled LSPs in the network without any IPv4. That is what I would say, well, we might not need then IPv4 in the core anymore. Well, I did also this one with 2 VPN sites, and in the forwarding plane, again, do you see IPv4 addresses here? No. For the VPN use case, it turned out that you do need IPv4, so I cheated it a bit on this slide. Yes, transport signaling for MPLS is resolved. You can run MPLS over IPv6 pure networks at this moment. However, there is not much of a use case for that because most of the MPLS services don't still work, still are not fully operational. None of the vendors so far supports IBGP over IPv6. Just to be clear, when you do router BGP something on Cisco, for instance, or in Quagga, if you I tried to get multi-protocol BGP over IPv6 endpoints, it turns out to be you cannot run IPv6, you cannot run yet developed. So the question is this an implementation or standards issues? Well, the answer is this one. Someone smarter and more hardworking guys and a lot of vendors contributing, Cisco, Juniper, Huawei, Nokia, and so on, sat around the table and made an inventory. And anyone running MPLS should read this really nice informational RFC. And this is the most important part in the RFC, the table from the last chapter, summarizing what works and what doesn't. LDP transport does work, so the work is completed and there is an RFC on that. However, layer 2 VPNs and layer 3 VPNs, there are gaps being discovered. The most serious one is layer 3 VPNs, although they should work with IPv6 next hops. In the forwarding plane it does. For the signaling part, still some things are not cleared. And as you see, when you set addressed in, you will see TBD. to be done. So at this moment, people are being assigned within the appropriate IETF working groups to fix the gap. For home and mid modules, management things are being identified and it is being worked on. Last slide to conclude this presentation. If you run MPLS in your network, either you are an IP operator or most of the times you're a mobile operator, you will still unfortunately need IPv4 and you cannot build it still over a pure IPv6 only network. If you want to run IPv6 over MPLS, you can do it using 6P or 6VP, so no doubt about that. But if you want a really IPv6 only network without any IPv4, unfortunately, you still do rely on that. There are some newer developments that will probably replace MPLS VPNs and layer 2 and layer 3 VPNs, although those developments are being very, very slowly adapted. One of those is Spring v6, Jan is looking at me, being pushed by only one big operator worldwide, but that operator turns out to have some other requirements, so it was not something that everyone envisaged to be. However, the IETF working groups, MPLS related working groups are actively working on fixes, and in the years that are coming we'll see that both more and more implementations that will allow you to run MPLS over a pure IPv6 network. Thank you.
Thank you, Barry. We have questions?
We do. People are lining up.
Where is the chair? Can I speak?
Yeah, sure.
Yes, you can speak.
Okay. My name is Jan George, and I'm speaking here on my own capacity as a very concerned internet citizen that hates complexity in the networks. And I would like you also to take off your Juniper hat.
Yeah, sure. This was, by the way, also from my some personal views.
And
so
I like your honest opinion. You're calling it Spring v6. Other people call it segment routing. Do you think it will stick? Do you think it solves anything? Do you think this is the way forward?
Well, depends on the angle, how you're looking on. If things are that people are looking for a solution to manage their own traffic streams, people are not happy with destination-based forwarding anymore. So Spring was a solution to that. It is not something that is carved in stone, nor it will solve all problems. It is just offered as a nice tool that you can use from your SDN controller to steer traffic. And by the way, Spring does address some complexities in the MPLS world because it removes MPLS signaling and allows you to use only Spring because it is being piggybacked on IGP. So you can use extensions of ISS and OSPF to run also MPLS signaling. You don't need LDP or RSVPT in that case anymore. So that's already a simplification in that world.
But Spring still needs the header injection things. That is a bit controversial topic now at the IETF, right?
Yes, well, it's not header injections, it's MPLS label injection. That's one of the things. If you're looking into the Spring MPLS part, if you're looking in the Spring v6 part, you're using indeed extension headers for IPv6, and then you're using header injections.
Yeah, but always my basic question is all this complexity worth the outcome? That's what's going on through my head.
Yeah, it's well, as I said, it is one of the solutions, but it's far from perfect.
Thank you, Marco.
Thank you, I'm Marco. How can we help? I know it's a problem. I've been following Sunset 4 in ITF as well. not a very optimistic timeline. So, question to you, how can we, this room, help you to expedite this blocking issue and make it disappear?
Well, one of the things that can be done at the short term is, as I said, is to cover MPLS services, especially layer 3 VPNs, which are not being, by the way, only popular because customers are looking for them. I was working with cable operators, and cable operators like to separate routing contexts because of security, and they want to limit certain that they're using most of the times VPN mechanisms internally to carry out traffic for different classes of service, different, for instance, they separate management networks, different management networks in different VPNs. So the question is, yeah, for layer 3 VPNs, I think the most of the things is that we need a stable implementation of multi-protocol BGP and a clear standard, which is, by the way, already written, but needs some clarifications on how we address, for instance, signaling of IPv4 VPNs over IPv6. That's not clear yet. So how do we cover all use cases? IPv4 over IPv4, it's clear. IPv6 over IPv6, more or less clear. But the mixed cases, we still need clarifications and implementation add-ons.
Thank you. Any other question? Thank you, Barry, for a very nice presentation.